Because the PX137 is a strain gauge based transducer, the voltage you'll read on these two lines, the output lines, is going to be quite low, in the millivolt range. And as such, you'll need to amplify it once again to get it into the Arduino at a reasonable readable voltage. So we'll use the INA125 chip again, just like we've used all along. We'll use a similar hookup to what we've used before. Power on the first pin, also connected to the second pin so that we get a full power supply and we keep the chip awake. Ground to pin 3 so that we've got the power supply grounded. And also ground to pin 12. Pins 6 and 7 will be the green and white inputs from the PX137. And across pins 8 and 9, we'll have a gain resistor connected. After we figured out what the gain resistance ought to be so that we get an appropriate gain, we'll be able to get the output on pins 10 and 11. Pins 10 and 11 need to be connected together, and they'll go off to pin A1 on the Arduino. One thing that's a little bit different this time, I've chosen to use pin 13 instead of pin 14. Pin 14 was 2.5 volts pseudoground. Pin 13 is a 1.25 volt precision voltage, so I'm moving the pseudoground voltage down a little bit. That puts me in a better range to get better resolution. And again, I've got this connected right around to pins 4, and 5, so that I've got the pseudoground correctly hooked up. So don't forget that pin 5 connection. System won't work properly without it. We need a load resistor here to allow the current, some current to flow from the output so that we don't have noise problems. And we'll connect that to our pseudoground up here. We're also going to connect the pseudoground, just like last time, to pin A0 on the Arduino so we can monitor what it actually is.